In this video, you will talk about distribution of target class and word frequencies in uni, bi, and trigrams. Before we go on, let me introduce the dataset we will use throughout the module. The dataset we will use is a data used on research on automated classification of document citations for systematic review of 15 drug classes. The original dataset contained 18,733 articles, but to ease our computational capacity, I reduced it to 10,000 instances to include 9 drug classes only. By the way, what is systematic review? Systematic review refers to a literature review that is designed to locate, appraise, and synthesize the best available evidence relating to a specific research question to provide informative and evidence-based answers. The original dataset is a gold standard data file of drug review topics, EndNote ID, PubMed ID, abstract triage status, and article triage status. Please go to Jupyter Notebook and run the codes there to get the final dataset we will use. After pre-processing of our data, it looks like this. There are topic, article IDs for PubMed, which is called PMID, a decision column where E denotes excluded and I denotes included for systematic review of each drug class topic, raw text for abstract, and pre-processed abstract text column. As you can see here, a majority of articles were excluded or irrelevant for the systematic review of AC inhibitors. Well, we don't have any idea about the inclusion criteria the authors of the systematic review established, but this is the decision the researchers have made. This graph shows the overall distribution of target class, that is, the number of excluded and included articles in the entire dataset. In this graph, included articles were marked 1, and excluded articles were marked 0. As you can see, only about 15% of articles in the entire dataset are relevant to corresponding topics. We can say the dataset is imbalanced. That is, there are much more zeros than ones in the dataset. In simple terms, an imbalanced dataset is one in which the target variable has more observations in one specific class than the others. Let's suppose that we have a dataset used to detect a fraudulent transaction. If we have a binary target variable that is 2 classes, that's 1 when the transaction is fraudulent and 0 when it isn't. It's normal for less than 1% of the observations to belong to class 1 or fraud than to class 0 or not fraud. In this case, we have a highly unbalanced dataset. Imbalanced classes are a common problem in text and data mining where there are disproportionate ratio of observations in each class. Class imbalance can be found in many different areas, including medical diagnosis and spam filtering.